Welcome everybody. Today we'll be focusing on exponential function. So let's start. Equation of the exponential function. It is as follows. Y is equal to a times b to the power x minus p plus q. The parameters: p shifts the graph left or right, q shifts the graph up or down. You already know that. Now b represents the base, which results in either an increasing or decreasing function. So here if b is in between 0 and 1, so which means b can be 0.1 up to 0.9. For example, 1 over 4, half, and 5 over 7. Those are all in between 0 and 1. They are not 1 or more than 1. So here's what a graph like that looks like. A graph would be in between 0 and 1 looks like this. For example, y is equal to half to the power x, or y is equal to half to the power y is equal to a quarter to the power x, or y is equal to half to a half to the power x. Now on this one, guys, you have to apply your knowledge of exponential functions. This is where you must apply your knowledge of exponential functions. So you must make sure that you're good with your exponents in order to master this function. Now, so this one, when b is in between 0 and 1, this function is a decreasing function. As x increases, y decreases. So remember this shape that you're seeing right here. B is in between 0 and 1. So that's what your graph has to look like if the value of b is in between 0 and 1. It's a decreasing function. As x increases, y decreases. Then here we have b greater than 1. When b is a number bigger than 1, for example 2, 5, 3 over 2, here's what the graph looks like. We have an example there: y is equal to 5 to the power x, or y is equal to 3 over 2 to the power x. So the function is an increasing function. As you can see here, it goes like this. So if you see it going like this, then you must know instantly that b is greater than 1 and it's an increasing function. So as x increases, y increases. Now let's talk about the domain and range of the exponential function. So the domain is always x, the element of all real numbers. Then the range, when a is greater than 0, b greater for b greater than 1, and b is in between 0 and 1. Y is the element of q is to infinity. So what's important there is a greater than 0 for both of the graphs. So both of the graphs, if a is greater than 0, the range is y is the element of q is to infinity, or you can just say y is greater than q. Right. When a is less than 0, b greater than 1, and b is in between 0 and 1. That means for both graphs, increasing function and decreasing function, y is the element of all real numbers. I'm sorry, I made a mistake there. Y is the element, it's supposed to be y is the element of negative infinity to q. So cancel that. Y is the element of negative infinity to q, or y is less than q. That's all. So we move on. Reflections of exponential functions. To reflect about the x-axis, we negate y, which means make y negative, as shown in this example. So you negate y, that becomes negative y, then you divide both sides by negative, which gives you y is equal to negative a half to the power x. And then to reflect about the y-axis, we negate x. For example, here y is equal to 2 to the power x. Y is equal to 2 to the power negative x. So as you can see, I negated x there. Y is equal to 2 to the power negative 1 times to the power x, which is, so 2 to the power negative 1 is the same as half x. So can you see that negating this x gives you it gives you a what's this? It gives you a decreasing function. Can you see that it gives you a decreasing function? So negating it when it's an increasing function results into a decreasing function. Yeah. So we move on. Asymptotes, we only have one, which is y is equal to q.